Hey guys, welcome to my video on 14-1 trigonometric identities. We are starting chapter 14 today, the very last chapter of the year. The aim for today is to verify and simplify trigonometric identities. So to start us off, we're going to recap reciprocal trig functions that we looked at in chapter 13. Okay, so each primary trig function, sine, cosine, and tangent, has a corresponding reciprocal trig function, right? Because the ratios of sine, cosine, and tangent can be flipped to create these. So the reciprocal trig function associated with sine is called the cosecant, right? We know the symbol for the cosecant is C, SC of whatever our theta is. Cosine's reciprocal trig function is called secant, which we know has the symbol SEC to represent it. And tangent has the reciprocal trig function of cotangent, which has the symbol COT. So when we talked about these before, we talked about how the ratios opposite over hypotenuse can be flipped to hypotenuse over opposite when we do the reciprocal trig function. Same thing for cosine. Adjacent over hypotenuse can be flipped to hypotenuse over adjacent. Tangent opposite over adjacent can be flipped to adjacent over opposite, right? So that's where we started with these reciprocal trig functions. But I also gave you another way to look at reciprocals. Okay, remember, a reciprocal can be rewritten as 1 over what is given. Okay, so when we talk about trig identities, we're going to be using that representation to make substitutions to help us simplify. Okay, so first off, what is a trig identity? Well, it's a trig equation that is true for all values of the variable for which all expressions are defined. Okay, so when we're talking about theta, there may be some values that don't work. Remember, we talked about asymptotes in the last chapter. The thetas that work for these identities have to work for every trig function within the equation. That's the only issue. Okay, other than that, everything we do can be done with algebraic work. So for instance, remember how I said cosecant and sine were reciprocal trig functions? Well, that means cosecant can be rewritten as 1 over sine. And sine can be rewritten as 1 over cosecant. Okay, now where is this beneficial? Well, it's going to be beneficial when we try simplifying things and we need to rewrite our trig functions in another way. Okay, we're not going to be evaluating them. We're going to be simplifying. Now that's going to be true for the other two primary trig functions and their reciprocals, right? We can write it as 1 over and make those substitutions. Tangent identity, we already talked about this. Tangent is equal to the sine over the cosine. We used that to make calculations in the last chapter. Now we're going to be using it to help us simplify in this chapter. Okay? And cotangent, knowing that it is the reciprocal of the tangent function, follows that it is the reciprocal of sine over cosine. So your cotangent function is equal to your cosine over your sine. So now, what's so great about this? Well, notice this equal sign for all of these identities. Okay? That means we can make a substitution in either direction to help make questions simpler. Okay? So if I see a tangent, it could help me to substitute in a sine over cosine to help us reduce. And that's the idea that we're going to be working with all of the trig identities that we look at today. Okay, so the first thing we're going to do is we're going to verify an identity. Okay, so we're given this, and we want to show that this side of the equal sign is equal to that side. Okay, so to do this, we need to make sure that we identify the more difficult, more complicated side of our equal sign and stick with only working with that side, okay? Because what we're trying to do is show that this eventually can be turned into a sine, can be made to look like sine of theta, okay? So we're not going to make any changes on this right-hand side of our equation. Okay, so looking at cosine and tangent, is there any substitution that can be made that can help us simplify? Well, typically with these identities, we want to simplify by turning things into sines and cosines. Okay, so cosine, obviously, we have to leave. But tangent, we know, is equal to sine of theta over cosine of theta. So we can make a direct substitution for that. Now, it may look more complicated than it was before. However, we know when multiplying, because that's what's happening here, we can do some cross-canceling. So if there's anything ever that is the same in my numerator and my denominator, I can cancel them out and am left with just sine of theta equal to sine of theta. Okay, so again, notice we stuck with the more complicated side. We turned it into sines and cosines, and then we performed our operations and simplified. Okay, those are going to be the steps we do every time we verify. Okay, so sometimes they just tell you to simplify. So the only difference really between verifying and simplifying is that they give you the form that they wanted to see. We wanted to see sine of theta. Here, we have to just do manipulating as best as we can to get it in its most simplified state. Okay, so again, we're going to turn anything that is not a cosine or a sine into something with that. So sine we can leave. Cosine we can leave. But again, that tangent can be substituted with sine over cosine. Okay, right? We make that substitution. We know those are equal. Now, if we look at these numerators and denominators separately, first we want to simplify as best we can. So in our denominator alone, we see cosine and cosine, numerator, denominator, can be simplified. Okay, so what does that do? Well, that leaves us with just a sine in our denominator. Okay, so I put the sine in the denominator, bring over the numerator. Again, we have something the same in my numerator and my denominator, so they cancel out. When two things cancel out, we know that it just simplifies to a 1. So this trig expression is actually just equal to 1. Okay, now if you wanted to verify this for yourself, you could plug in any number in for theta in all three places, and you should see that it's equal to 1. Okay, so there are a few more identities that we have to look at. Okay, we have what are called the Pythagorean identities, which are derived from the Pythagorean theorem with triangles on our coordinate plane. We won't get too deep into that, okay, but just know that something that you should be very familiar with is this first sentence right here. Cosine squared plus sine squared equals 1. I tend to say sine squared plus cosine squared is equal to 1. Again, commutative property says the order, and that doesn't matter. Okay, that is a Pythagorean identity. Now, the other two below it are actually Pythagorean identities that can be derived from that cosine squared plus sine squared equal to 1. Okay, so these are also identities. So what can we do with these? Well, anytime I see cosine squared plus sine squared, I can substitute a 1 or vice versa. Anytime I see 1 plus tan squared, I can substitute in a secant squared. Anytime I see a 1 plus cotangent squared, I can substitute a cosecant squared. Again, one side is a little bit simpler than the other, so we're going to be using that to our advantage. One thing we have to be aware of is that this notation, sine with the 2 in between, is the same as saying the entire sine function is squared. It's to help prevent us making a mistake with the angle being squared. It's the entire sine function, okay? So anytime you see that, think of it as having that entire sine function squared. So now these are one way of looking at it. This is the way the textbook tells you on page 906. But these can be actually rearranged and come up in any format when you take a look at our identities and simplifications later on. So we know that we can move things around. So if I were to subtract a cosine in this first one from both sides, I would see that sine squared theta would be equal to 1 minus cosine squared theta. Okay, so that's another way of writing this identity. Okay, so again, when we see addition subtractions, we should be thinking these ones. Another thing I could do is subtract sine from both sides. So that means cosine squared theta is equal to 1 minus sine squared theta. Again, can be substituted in either direction. Okay, now how do we get to 1 plus tan squared theta plus secant squared theta? Well, it comes from taking this equation and dividing every term by cosine squared theta. We know we can do that because we're doing the same thing to both sides. So cosine squared theta plus sine squared theta is equal to 1. If I divide everything by cosine squared theta, what happens? Well, cosine squared theta divided by cosine squared theta gives me this 1 right here. Sine squared theta divided by cosine squared theta. Well, sine over cosine is tangent, so sine squared over cosine squared is going to be tangent squared. And 1 over cosine squared, well, 1 over cosine is equal to secant, so 1 over cosine squared is going to be secant squared, okay? So that's how we get this identity. Now, we can rewrite this in 2 different ways, right? Moving things over. The first thing that I can do is I can subtract the tangent on both sides. So that means 1 is equal to secant squared theta minus tangent squared theta, okay? The other thing I could do is subtract 1 from both sides. So tangent squared theta is equal to secant squared theta minus 1. Okay, so those are other ways this could be represented. And last but not least, we have 1 plus cotangent squared theta plus cosecant squared theta. This comes from taking that equation, cosine squared theta plus sine squared theta is equal to 1, and dividing it by, hopefully you guessed it, sine squared. Sine. Sorry, my handwriting is not great today. Okay, so what happens here? Well, we know sine squared theta over sine squared theta is the same thing. That's equal to my 1. And cosine over sine is equal to cotangent. So cosine squared theta over sine squared theta is equal to cotangent squared theta. And 1 over sine is equal to cosecant. So 1 over sine squared is going to be equal to cosecant squared. Okay, so now what can I do with this to get my other 2 versions? Well, again, I can do some manipulating. I could subtract cotangent from both sides to get that equivalent. Or I can subtract 1 from both sides and get this equivalent. Okay, so now it is fair game for it to show up in any of these formats, okay? So anytime we see an addition or subtraction, we should be going back to this page and referring to these Pythagorean identities, okay? So let's see how these can be used. So we're going to go with the same pattern. Verify the identity, okay? We're going to start with one side and do our best to make it look like the other side. So the question is, which one's more complicated? And we're going to do the addition or subtraction, okay, because it's a lot harder to create addition or subtraction from multiplication than in reverse, okay? So let's stick with this left-hand side right here. What can we do with this? Well, typically we try to reduce it down to sines and cosines, okay? So sine is fine, but cosecant we know is the same as 1 over sine theta, okay? So I can make that substitution. Well, now I need to work with this. How can I bring these 2 additions or subtractions together? Well, it might be to my advantage to make it into one big fraction, okay? Because again, we want to try to get to multiplication in some way. So one single fraction might help me with that. Well, in order to do that, I need to make sure they have like denominators. So I have to multiply this by sine over sine, right? That one fraction needs to have the same denominator. So I get sine theta minus, what is that? Sine squared theta in my numerator over sine of theta. Okay. And now since they have the same denominator, I can bring them under into one fraction. Okay. So now what's left? Well, I see a 1 there, so I should be thinking, identity, identity, identity. What can I use? Well, if we go back up, 1 minus sine squared theta is right here. Okay, so that means I can take that and substitute in cosine squared theta, which is exactly what I'm going to do. So let's go back. Take my numerator and fill in cosine squared theta over sine theta. Okay, so now again, I want this to look like cotangent theta times cosine theta. Well, those are two different multiplications. So what can I do with this? Well, I see I could have two different multiplications because I have cosine squared. We know that's the same as cosine. I'm just gonna bring this up here. Cosine times cosine, all over sine. Now, since it is multiplication in my numerator, that denominator does not have to go to both of them, so I can just group it with the first one. So cosine theta over sine theta times cosine theta. We're getting there, right? Because cosine over sine, hopefully we remember, is equal to cotangent of theta. Okay, so now did I make it there? Did I get from here all the way to this expression? I did. Okay, what were some of my techniques? Well, combining addition or subtraction into a single fraction, substituting identities, splitting apart multiplication, okay, and some strategic grouping, okay, but in the end we did get that, so we are good. Okay, excellent. Now, if I had more space, I would leave the equal to cotangent theta on that side and bring it with me. But due to space, I did not do that. Okay, let's take it a step further. Simplifying without knowing where we need to be. Okay, what substitutions can I make? Well, I see a 1 plus, so that should be telling me Pythagorean identity. Okay, so we go to our Pythagorean identity checklist, okay? Where do I see this question? Well, 1 plus cotangent. Oh, I made a mistake here. Sorry about that. This should be a 1. 1 plus cotangent is equal to, there we go, this identity right here. Okay, so we could substitute cosecant squared theta. And that's what I'm going to do. Sine of theta and substitute cosecant squared, because we have squared theta. Are there any other simplifications I can do? Well, again, I want to, once I've simplified these addition subtractions, I want to turn it into sines and cosines. Okay, so cosecant squared theta is the same as 1 over sine squared theta. Okay, so now this is a multiplication. Are there any other simplifications I can do here? Well, we have 1 sine in my numerator and 2 sines in my denominator. I can cancel, which would leave me with 1 over, I don't like that color, it's too light, 1 over sine theta. Now again, 1 over sine theta is not its most simplified form. We know this is equal to cosecant. Okay, so my final simplification is cosecant of theta. So this expression right here simplifies all the way down to this single trig expression. Okay, so now I'm going to ask that you pause the video and give this last one a try. Okay, use your identities, manipulate the best you can, see what you can do. When you're done, unpause the video. Okay. So what can we do here? Well, I see a lot of pluses, and that's a good thing. because pluses tend to mean Pythagorean identities. So which Pythagorean identity can I use? Well, sine squared theta plus cosine squared theta we know is equal to 1. So I can substitute a 1 in for that and bring along the 1 tangent squared theta. Okay, now again, we have a 1 plus something. That's good. That means we're probably going to use a Pythagorean identity again. So go back to your page and see what this equals to. You will see that it is equal to secant squared theta. Now, there's not much I can do here. We're down to a single trig function. There's nothing else I can cancel. There's nothing else I can substitute. So we are left with that as our final answer. Okay? All right. Now, there's one last thing we can do with Pythagorean identities, and the thing we can do is use them to help us calculate actual trig functions. Okay, so for example, number 56 on page 909. Given that the sine of theta is equal to 0.5 and theta is in the second quadrant, what are cosine theta and tangent of theta? Well, up until this point, we used to have to, draw our quadrant. I'll say, okay, we have sine in this quadrant. Oh, it's 1/2. Let me draw a triangle. Well, guess what? Now that we have a relationship between sine and cosine, we no longer have to do that. Okay? We can actually make a direct substitution of 0.5 in for sine and square it into this equation. Okay? And from there, all we are left with is one last trig function. Okay? So we can solve this by first squaring. So I get 0.25 when I square that. I want to bring it over because I want to isolate my cosine. Cancel. I got cosine squared theta is equal to 0.75. And now I'm here at cosine squared is equal to 0.75. Well, we know cosine squared theta is equal to cosine of theta squared. Now, if I wanted to get rid of that square, we know that square root can cancel it out. So if I take the square root of both sides, it will cancel out the square and leave me with just cosine of theta. Okay, on this side, we get plus or minus the square root of 0.75. Now, we shouldn't be happy with 0.75 because we tend to like things as exact as possible. Okay, so we know 0.75 is equal to what? 3 over 4. So that's really equal to radical 3 over 2. So the value of my cosine is equal to plus or minus radical 3 over 2. Okay? Now, here's where that second quadrant comes in. If we are in quadrant 2, all students take calc. That means that sine is positive and cosine is negative and tangent is negative. Okay, so we don't even need the plus or minus. We are just going to take the negative value. Okay, so we found our cosine of theta. It's equal to negative radical 3 over 2. Check. Well, how do we find our tangent from that? Well, let's think about it. What do we have to help us find our tangent? Well, we have an identity. Tangent is equal to sine over cosine, isn't it? Well, if it's equal to sine over cosine, we can substitute a value for sine. 0.5 is equal to 1/2. And substitute a value for cosine. And do regular operations. So keep, change, flip, cancel, cancel. We get minus 1 over radical 3, which we know when we rationalize gives me minus radical 3 over 3. Okay? And there we have it. Is it negative? Yes, and it should be because we are in quadrant 2. We are done. Okay? So pause the video and give this second one a try using the same skills. The last question for the day. When you're done, unpause the video. Okay, we are given that sine is equal to 0.2. Tangent is less than 0, and we're trying to find cosine. Okay, well, if we given a sine, we want to find cosine, we can use the trig identity. Sine squared theta plus cosine squared theta is equal to 1. 0.2 squared can get substituted. That is equal to, well, I actually turned that into 1/5. So that's 1 over 25 plus cosine squared theta is equal to 1. Subtract this. Minus 1 over 25. And I get cosine squared theta is equal to 24 over 25. Take the square root of both sides. I get cosine, not squared, of theta is equal to plus or minus radical 24 over radical 25. That simplifies to 4 times 6 over radical 25. That is plus or minus 2 radical 6 over 5. Okay, and I got that from squaring it. Okay, so we have that. So now we have to decide about the signs. Well, if I'm on my coordinate plane and my sign is positive, that means I'm either in quadrant 1 or quadrant 2. Those are the only two places where sign is positive. Okay. Now, if tangent is less than 0, that means tangent is negative. So what does that mean on my coordinate plane? Well, tangent cannot be negative in quadrant 1. That means we are in quadrant 2. So which sign do we take? Do we take a plus or do we take a minus? Well, since we're in quadrant 2, cosine is negative.